Here's problem 2933. A current loop is oriented in three different positions relative to a uniform magnetic field. In position 1, the plane of the loop is perpendicular to the field lines. In position 2 and 3, the plane of the loop is parallel to the field as shown. The torque on the loop is maximum in which configuration? In general, the torque on a current loop as a vector is going to be equal to the number of turns times the current area vector crossed with the magnetic field. The magnitude of this torque then would be equal to the number of turns, current, times the area, times the field, times the sine of the angle between the area vector and the magnetic field due to the cross product. Well, if we look at the first loop, we have a magnetic field that is going to the right like this, and the area vector is always normal to the surface that it represents, so the area vector is also going to the right, or possibly if the current were going the opposite way, it would be going 180 degrees opposite this direction. In either case, we're either going to end up with a sine of 0 degrees or the sine of 180 degrees, and for both those cases that's 0. So their torque in this case is going to be 0. We want to have maximum torque. In the second case here, we have a magnetic field going to the right, and our area vector is perpendicular to the area it represents, so it's coming out like this with a perpendicular or 90-degree angle in relation to the magnetic field. Or the area vector is going on the other side of this plane but also perpendicular. So our theta in either case is 90 degrees. Sine of theta will be 1 because we have sine of 90 degrees, and our torque would be our maximum torque. The maximum torque possible because the sine of theta is the maximum value possible. So that one works. In the last configuration, we have a magnetic field that's going to the right, and our area vector again would be coming out of the page towards you, or possibly going into the page away from you, but still at a 90-degree angle with the magnetic field. So theta is 90 degrees, sine of 90 or 270 is going to be equal to 1, and hence our torque will be our maximum torque because the sine value is its maximum possible value. So in positions 2 and 3, we will have our maximum possible torque where the plane of the area is in the same direction parallel with the magnetic field.